We're now going to solve problems involving three variables. And these will also have three equations. So here's our example. The Mowing 'em Down Lawnmower Company manufactures three styles of mower. The 21-inch model requires 2 hours to mold, 3 hours for engine manufacturing, and 1 hour to assemble. The 24-inch model requires 3 hours to mold, 3 hours for engine manufacturing, and 1 hour to assemble. The 40-inch riding mower requires 4 hours to mold, 4 hours for engine manufacturing, and 2 hours to assemble. The company has 81 hours to mold, 95 hours available for engine manufacturing, and 35 hours to assemble each day. So this is our hint as to what our three equations are going to be. One equation is going to handle the molding. Another one is going to handle the engine manufacturing. And the last one is going to handle the assembling. And the way I know that is because that's the total. We always have some total. And so we have 81 for molding, 95 for engines, and 35 to assemble. So our variables then are the 21-inch, the 24-inch, and the 40-inch. And so here, we just come in and we notice for the 21-inch, I'm going to go down. So that's 2 hours to mold, 3 for the engine, and 1 to assemble. Our 24-inch is 3 hours to mold, 3 engines for the engine, and 1 hour for assembling. Our last one is the 40-inch ride-on, is 4 hours to mold, 4 hours for engine manufacturing, and 2 hours to assemble. So now all I need to do is come in, and let's call this my X, this one my Y, this one my Z, and we just throw plus signs between them, and we can figure out our equations. So notice that we have one equation, two equations, three equations, one variable, two variables, three variables. Now that I've turned this into a three equation, three variable, we can simply name it. This is 1, this is 2, this is 3, and we pick a variable to eliminate. And I'm going to pick z's because 2z and 4z is really easy. In fact, I'm going to use the same thing from 3 twice, so that's going to help me get rid of my z's. So we're going to take equation 1 just as it is, and I'm going to subtract 2 times equation 3. So 2x plus 3y plus 4z equals 81. Minus 2x minus 2y minus 4z equals minus 70. We add these together, and oh look, we got a bonus. Not only is the x's going to eliminate, not only is the z going to eliminate like I was planning on, but the x's are too. X's are gone, z's are gone. That leaves me with y equals 11. So now I know that my 24-inch I have 11 of. That speeds things up tremendously. In fact, let's see what happens with our other equation. If we take equation 2 and subtract 2 times equation 3, we're going to get 3x plus 3y plus 4z equals 95. And here I can just copy these same numbers. Minus 2x minus 2y minus 4z equals minus 70. Add these together. Not quite as nice. The x's and the y's don't eliminate. No, the x's don't eliminate like they did before, but we still get 1x plus 1y with no z's equals 25. Well, we already know that y is 11 from our last problem, so we can just replace that with this one. Subtract 11 from both sides. Oops, that should be a 25, getting just a little ahead of myself. Subtract 11 from both sides and see that x is 14. So y is 11 and x is 14. To get z, we pick any one of our equations and we plug in. I'm going to take the third one because it's got the smaller numbers. 14 plus 11 plus 2z equals 35. Well, that's 25 plus 2z equals 35. Subtract the 25, 2z equals 10. Divide by 2, and z equals 5. So what this means is, this company can make 14 21-inch lawnmowers, 11 24-inch, and 5 40-inch riding mowers with the specifications that they have given us. So by converting it to a system and then solving it, we're able to solve the problem.